Hello everyone, in this video we are going to see how we can implement the shortest job first CPU scheduling algorithm in C and C++ program. Okay, so let's see. So I have taken this example to understand the program for the shortest job first. So as you know, shortest job first is a non-preemptive CPU scheduling algorithm. That means if let's say at current point or let's say at t equal to 8 unit of time, we have these number of processes, okay, P1, P2, P5. And let's say this P1 is having the burst time as 2, this P2 is having the burst time as 5, and this P3 is having the burst time as 3. Then first the process which is having the minimum burst time, it will be selected. Okay, this is meant by the shortest job. Okay, so this P1 will be selected first and it will be given to the CPU for execution. Next time, out of P2 and P5, this P5 will be selected because out of 3 and 5, this 3 is the minimum CPU burst time. Okay, so P5 will be given to the CPU. Okay, and at last this P2 will be given to the CPU. So based on the CPU burst time, the processes are chosen from the ready queue by the scheduler and they are given to the CPU. Okay, so the main thing is we have to select the process having the least burst time at current point of time. Okay, and what do you mean by non-preemptive? Non-preemptive means, let's say if P1 is having the burst time as 2, then if P1 is given to the CPU, then it will run for 2 unit of time completely. Okay, it cannot happen that P1 is running and only 1 unit of the P1 has been completed on the CPU and then P5 can just snatch the CPU from the P1. It will not happen because this SJF is a non-preemptive algorithm. Once the process is given the CPU, it will complete itself, then only it can leave the CPU and next process can come to the CPU for execution. Okay, we will see in the next video that shortest remaining time first or shortest remaining time next, that is the preemptive version of this shortest job algorithm. Okay, so here is the Gantt chart, and in this Gantt chart I have shown the completion time of each and every process. So our program should take the process number, arrival time and CPU burst time as the input. And in the output, I want all these informations like turnaround time, the waiting time, response time of each of the process, throughput, and the CPU utilization percentage. And I also want the average turnaround time, average waiting time, and average response time also. Okay, so these should be the output of my SJF program. Okay, so just for your understanding, I have written the completion time, turnaround time, waiting time, and response time of each and every process here so that you can later on verify your answer by the code. Okay, so if you're not comfortable with how this SJF actually works, so you can see the concept of this SJF and the numerical of SJF in my playlist of the operating system. So you can find the link of that playlist in the video description below. So you must watch those videos before you understand this C program. Okay, so now let's see the algorithm for this shortest job first implementation. So here is our algorithm. So here you can see first we are asking the user the total number of processes that it want to enter. Then we are asking the arrival time of each and every process. Okay, and then we are asking the, so first we are asking the, so this is the algorithm. So here first we are asking total number of processes that we want to enter. So here in this example we have total 5 processes. Okay, so let's say we have n equal to 5. Then we will ask the arrival time of each and every process. So these are the arrival time. So we will ask all these 5 arrival times. Then we will ask the CPU burst time like we have shown here. Okay, so for each of the n process we have to enter this information. And based on this information, we have to compute all the things like completion time, turnaround time, waiting time, and their averages and all these things. Okay, and finally we have to print the answer. Okay, so this second point, or you can say this second part, it is the main part of the SJF because all the processing is done here actually. Okay, at last we have just print the outputs, that is this completion time and all. Okay, so we have to understand this thing. But before proceeding further, we have a question. The question is how to group the information of the processes. That means a process has many information. You can see process has arrival time, each process has CPU burst time, completion time, turnaround time and all. Okay, so there are many information associated with each and every process. And for each process, all these informations are present. So how we can store all these informations for a particular process into a C program or any programming language. Okay, so although we have discussed this answer in the previous video of the FCFS program implementation, so might be you have got the answer. So the answer is we can use separate arrays to store the arrival time and separate array to store the CPU burst time. Okay, so for example, we have these two arrays. This array stores the arrival time. This array stores the bus time of each and every n process, right? Now there is a better way. Now here, if I want to store any, now here if I want to fetch any information of the, let's say, first process, that is the P1 process. Okay, so I'll take the arrival time from this AT array, and from BT array I'll be taking the bus time. Okay, but what I want actually that all the information of a particular process, they should be kept under a single name. They should be grouped together. Okay, here the information of the arrival time and the bus time, they are separated, right? So how we can group the related information? So the answer is structure. We can use the structure. As you can see here, we have the structure name as process struct, and we have these information, the PID, arrival time, bus time, and all these information. So we have actually taken a array of structure. So you can see here, this is the array of structure. Okay, so PS0 will store the information of the 0th process, PS1 will store the information of the 1th process, and so on. Okay, so we have a single name, that is PS, and under this single name, all the information of a particular process is kept here. So you know that how we can access the information inside the structure. So if we want to store, or let's say access this BT, we can say PS0.BT. This will give me this BT. Okay, the same way I can access any information, or I can store any information by accessing these structure variables. Okay, so now we have seen that how we can group the information of the various process using the structure. Now we will see that how we can scan the arrival time and the CPU bus time. So the number of process, we can just use scanf function in C and the cin inside the C++ language. Okay, and how we can enter the arrival time and CPU bus time for each of the process? So it is very simple. We can use the for loop or any of the loop. So here is the code. Here you can see this is the loop, and here we are entering the arrival time of each and every process along with the PIDs, and in this we are entering the bus time. So here we are scanning the arrival time PS of I.AT. So I will run from 0 to n, and along with I am scanning, or I am just pasting the I value inside the PID field of each and every box. Okay, so the first process will have the PID 0, this will have PID 1, this will have PID 2, and so on. Last will have the PID as n minus 1. Okay, and in this loop I am asking the bus time, that is this bus time. Okay, so you can combine this two loop into a single loop, and you can ask like arrival time, bus time, arrival time, bus time of each and every process. Okay, so it is up to you how you are implementing the things. Okay, so now let's move forward. So the next thing is, we have entered the information as the input. Now we have to process this information. So this is the main thing that we have to understand. Okay, so here what I have done is, I have taken two variables, current time and the completed variable. Okay, so completed variable will actually be telling me that how many processes have been completed till a particular time. Okay, so initially this completed variable will be 0 because no process has been completed. So let's say at particular point of time, let's say P2, P3 and P4, they are completed. So that means how many processes have been completed? 3. So completed variable will become 3. So completed variable will become then 3. Okay, and let's say one more process is completed, then completed variable will become 4. Okay, now this current time is able to track the time of the completion of the various processes. Okay, we will see that how we will use it. Okay, so inside you can say while loop. Here you can see inside while loop we have many statements, right? So this while loop is saying you have to run this while loop till all the processes are not completed. Okay, we have n processes, so completed variable is like a counter which is telling me that how many processes have been completed. So when this completed variable will equal to n, then only this while loop will be over. Okay, and then we will come out to print the required outputs. Okay, so it is saying if the completed is not equal to n, come inside. Now how SJF works? So this line is saying ki, please select the process which is having the minimum CPU bus time from this ready queue. Okay, so here what is the process having the minimum bus time? It is the P4 because it is having the 2. But this will not be case here. Why? Because all the processes, they are coming at different time. Let's say if the arrival time is 0 for all the cases, that means all the process will be coming inside the ready queue at 0 time only. All will be available. Then we can say, okay, that P4 will be the person or the process with the minimum burst time. But if the process is having the different burst time, then we cannot say just on the basis of CPU burst time that 2 is the minimum, so select this process, because this is available only at 8 time. Okay, so here one important thing is to note is you have to select the process with minimum CPU burst time from the ready queue till the current time. So initially current time is 0, which is the process having the least burst time till this current time as 0. So till 0 only this P1 is available having the 5. Okay, these process are not present inside the ready queue. So P1 will be selected. Okay, then we will be selecting the P1 and we will say, okay, if such process is found, okay, we have found the process P1. So we will come inside and we will find all the metrics, that's completion time, turnaround time for this particular P1, because this has to complete. Okay, because SJF is non-preemptive. Now P1 will take 5 units and it will complete itself, right? And after that we will say, okay, one process has been completed. So I'm saying completed plus plus. So completed plus plus, that means now this variable will become 1 because one process has been completed, that is P1, right? And after that I will say mark that process as completed. Okay, so why I am saying mark that process as completed? This means that this P1 will be marked as completed. And how I can actually say that this is completed? I will take a separate array, okay, and I will take the name as is completed in my code that we'll see later. Okay, and that will be initially false. Okay, or you can say it will have 0 value. Okay, so now P1 is completed, I will say 1, or you can say true. That means this process has been completed. And why I am taking this is completed array separately, and like what is the need, we'll see later. Okay, and after that I am saying, okay, this P1 is completed. Okay, so this P1 is completed at how much time? 5. This 5 is the completion time, so CT is the completion time. Okay, see, this is the pseudocode. I am not using the structure that ps of I dot ct. Okay, so this is just the pseudocode. We'll see in the code, actual code. Okay, that how this CT can be written. So the current time will now become as 5. Okay, so the current time is 5 now. Now we will go again and we'll say, okay, one process has been completed, but this is not equal to 5 because there are total 5 processes. So we'll again come and we'll find the minimum CPU burst time process till current time. Current time is 5. So till 5 p.m. you can say, which is the process having the least burst time? So here you can see there is no process which has arrived at 5 seconds. Okay, only P1 was there and that is actually completed. Okay, so this is completed array I will be using here actually. Okay, so here I will be using the is completed array to see that I have not to select this P1 because this is already completed, although this process is present before 5. Okay, but it is completed, so I do not have to take it. So this is completed will be telling me it is 1. It means it has been processed already, do not take it. Okay, so till 5 there is no process. So what I will do, my CPU will be idle. Okay, so till 6 seconds my CPU will be idle. How? So here there is no such process found, so I will just come to else and I will say current time plus plus, that is 6. Okay, 6. So I am increasing this current time by the step of 1 only when there is no process inside the ready queue. Okay, that is important. Okay, now when we go again, we'll say, okay, only one process is completed till now. Now at 6 time, is there any process which has arrived? Again, there is no process arrived. So again, we'll say if it's false, we'll say current time plus plus, that is 7. So we will say 7. Okay, now again at 7 point of time, when we go into the while loop again, there is no process. So again, we'll say just increment the current time, that is 8. Okay, now we come here and we'll say again this is 2 till 8. Is there any process that has arrived? We'll say yes. At 8 we have P2 and we have P4. Okay, so P2 is there and P4 is there. Now the situation is we are having 2 processes. Okay, but we have to select which process. We have to select the process which is having the minimum CPU burst time. So we are having 2 processes, and which is having the least CPU burst time? So P4 is having the least burst time, that is here 2. Okay, so what I will do now, I will run P4 and P4 will run for 2 unit. Okay, that means till 10. Okay, so from here P4 will be selected, and we'll say yes, such process is found, that is P4. We'll find all the matrix and CPU utilization and everything. Then we'll say okay, P2 is like completed, so we'll increase this completed variable, so it will become 2. Okay, so it will become 2. Then again we'll mark this process as completed. P4 will be marked as completed. So I think now you have understood that why we are marking the process as completed, so that in the next iteration that process should not be selected, because that process is already completed, right? So that's why we have to keep track of that completed processes by using this another array. Okay, now the current time is 10, so we have to update this current time. So the completion time of this P4 is 10. This will update this current time. This current time is 10, right? Now again we'll go and we'll say 2 process has been completed. Now come again till 10, which are the process that has arrived. So here you will see P2 is here, P4 has been completed. Now P4 has been completed, P1 has been completed. So till 10 we have this P2, we have P3 also because it arrived at 9, and P5 also. Okay, so P2, then we have P3, and then we have P5 in the ready queue. Okay, now out of these processes, which process is having the least CPU burst time? So 4, 6 and 3. This 3 is the minimum. So we'll select P5. Okay, so from here P5 is selected, and again we'll find all the matrix, and we'll say okay, P5 is having 3, so it will be 13. Everything will be completed. We'll say P3 is completed. We can say completed is 3, and then we'll mark this as completed. This P5 will be marked as 1, and then we'll say update this current time. So current time will now be 13. How? The completion time of this P5 is 13. 13 will go in the current time. Okay, so now in the clock you can say 13 is ringing. Okay, now again we'll say the process has been completed, and so on. We'll run this code for the next set of processes. Okay, so P5 is over. Now out of P2 and P3 we will select. Okay, so till 13 unit of time we have P2 and P3, and there are no new process that are coming. Okay, so out of P2 and P3 we'll select this P2 because it is having the least CPU burst time. So P2 will be selected, and this will be 13 plus 14, this is 17. Okay, so P2 was selected, everything was completed will become 4. Process is completed. Current time will be this 17, right? And finally we'll say there is one process remaining now, so we'll say okay, till 17 we have only this P3 is remaining. Okay, so P3 is remaining. Okay, this was already completed, so P3 is remaining. Okay, compute everything for P3 and then mark everything. So finally P3 is there, and P3 is having 6, so 17 plus 6, it will be 23. Okay, so lastly our this process P3, okay, there was some mistake here, that is okay. That means last process is also completed, and we'll say okay, mark this process as completed, and current time is 23. Okay, 23. Okay, so we have total 5 process that has been completed, and we'll go here. So now completed is 5 is not equal to 5, so wrong will come outside this while loop. Okay, and now we will print the required output. So inside this loop we will be actually calculating all this completion time of each and every process. We'll also be adding the completion the turnaround time, waiting time, so that we can find the averages. Okay, to average we want to find the sum of all this waiting time, turnaround time, and the round response time. Okay, so we'll do that calculation also, but that was the major part. This is the major part that we have to understand. Okay, so till all the process are not completed, you have to find the process till the current time which is having the least burst time, and if that process is there into the ready queue, we are just finding all the metrics, we are marking that as completed, we are updating the current time, and we are doing for each and every process. Okay, and if there is no such process found, okay, inside the ready queue, if there is no such process, then we are just incrementing the current time in the step of 1. Okay, we are incrementing by 1. Okay, but if there is such process, then we are updating the current time with the help of completion time. Okay, And after doing this, we are printing the outputs. Okay. Now you will be thinking that what is the code for this part? That is, how we can find the process with the minimum CPU bus time till the current time. So let's see the code for this part, because this is also important. So here is the code for this part. That is how we can find the process which has having the least burst time from the process available in the ready queue till the current time. Okay. So here you can see I have taken two variables. Okay. So for this we are seeing the code actually. So we have taken two variables, minimum index and the minimum. So minimum index will be telling me the index of that process which is having the least burst time. Okay. And this minimum variable will actually be storing that particular CPU burst time, that actual burst time. Okay. So let's say at any point of time, P3 is the process which is having the, let's say, least burst time. Okay. So these processes will be like stored in the array of structure. Okay. So this minimum index will be storing this 2. Okay. And this 6, this burst time will be stored inside the minimum. Okay. So this is the working of index variable and the minimum. Okay. Now what we are actually doing, we are saying, okay, initially what is the invalid index that we can store actually inside the minimum index? We can just store -1, because -1 is the invalid index. Okay. We can initialize it this way. As minimum variable will be storing the minimum CPU burst time. So I am initializing it with the maximum value. Okay. I think this is the simple code that you have studied in your first semester or in your lower classes. Okay. How we can find the minimum? So we are initializing it with the maximum number. So we can just initialize using this macro int max. So int max will initialize this minimum with the maximum integer value. Okay. Now inside this code, here you can see we are saying you have to run the loop from I equal to 0 to n. Okay. Always we have to run this loop from I equal to 0 to n. That means every time we will be scanning this whole complete array of structure, okay, to find the process having the minimum CPU burst time. Okay. So what we are doing, we are saying, okay, just check till current time, okay, which is the process that has not been visited or that has not been completed. So let's say currently we are having 3. Okay. The current time is 3. So till 3 o'clock, what are the processes that are arrived inside the ready queue? We are checking that one. Okay. So we are checking each and every process from 0 to 4, that if your arrival time is lesser than 3. Okay. So 0 is less than 3. Yes. So I will say, okay, I am taking you into the consideration. But along with, I will be checking whether you have been completed previously or not. Okay. So here I said that there will be an array which will initially be false. So let's say P1 has not been completed initially. So it will have 0. So this is also true. So for P1, both these conditions will be true. So I will come inside. And then I will say, okay, for you, what is the burst time? I will say 5. You have the burst time as 5. Then I will say, okay, what is the minimum burst time of the previous process, or till current time, what is the minimum CPU burst time that you have stored inside the minimum? So I will say my minimum is 5, and let's say minimum has this int max. Okay. So int max is a very large number. Okay. It can be like 327684 for 16-bit number, something like that. Okay. So this psi.bt, it will give me 5. 5 is less than this big large number. Okay. So I will say yes. So I will come inside and I will say, okay, you take me as the minimum. So in minimum, I will store 5 and index will be stored as 0. Okay. So this way it will be working. Okay. Now, when this thing will be working, I will tell you. See, the burst time can be less than your previous minimum. It can be equal to your previous minimum, or it can be lesser than your previous minimum. There can be 3 things. Okay. So that's why I have written less than minimum, equal to minimum. For greater than minimum, I will not be doing anything. Why? Because let's say at a particular point of time, you have seen, let's say 5 processes. Okay. Let's say you have seen 5 processes, and out of 5 processes, minimum was something X value. Okay. X value. And now you are coming into the next iteration, and now you are saying, okay, just check the current burst time of the ith process. If it is greater than your previous minimum, then you need not to update your minimum variable. Why? Because X will be the minimum only. Y cannot be the minimum because it is greater. So I have not written that condition. If this bt is greater than your minimum, then I am doing nothing. I am not updating the minimum variable. Okay, but if it is equal to minimum, then I am doing something. Okay, that I will tell you later. Okay, so if we run on this actual example, then initially the current time is 0. So I will say, okay, this process arrival time is actually 0. 0 is less than equal to 0. Yes, and it is not completed. So I will be selecting this process and I will be checking, okay, your CPU bus time is 5. It is lesser than int max. Yes, so I will say minimum is 5 and minimum index is 0. Now we have found the minimum. We will run into this condition also. This bus time is 5 and minimum is also now 5, but we will go inside and this will be false. Okay, why? Because minimum index dot at means this thing 0 and this is also 0. 0 is less than 0. This will be false. Okay, so this is actually not made for this part. Actually this is made for something else. We'll see later. Then and the next time for I equal to 1, again it will run. Okay, because it has to find the minimum from everything. Okay, till current time. Okay, so the current time is 0. Again it will go, okay, the current time is 0, but its bus time is 8. 8 is less than 0. No, so it will not run. Okay, so it will automatically false. So for all the other processes, because their arrival time is not lesser than equal to current time, so for all the other thing it will be false. So finally this will be giving me the p1 or the index. Okay, so this will give me the index. Okay, you have to take care. This will give me the index of the process having the minimum CPU bus time, that is 0. Okay, and that is stored inside the min index. So I was saying that here, if such process found, so that such process found will be checked by this condition. If minimum index is not equal to -1, that means minimum index variable is updated, then I am coming inside and I am finding all the things. Okay, so for the 0th index, that is for the p1, I will be calculating everything. Okay, so this way you can run this for the other processes also. Now, as we have seen in previously that this arrival time of P2 and P4 is same. At 8, P2 and P4 will be available. But we are actually running which process? We are running P4 first because its bus time is smaller. So this code should give me the P4 out of P4 and P2. See if it is working or not. So here you can see before P4, P1 has been completed. Only this was completed and the current time will be 8. Okay, so now if you come inside, again this thing will again be initialized with -1 and int max. So I will start from the 0th process. Okay, so I will come to 0th process. The current time is actually 8 and the is completed is actually 1 for this 0th process. So I will not come inside. Again I will come for I equal to 1. Okay, now for this process I'll see, okay, till 8 your time is 4. So I will say, okay, your arrival time is 8 and 8 is equal to 8. Okay, and you are not completed. So I will come inside. So I will actually select this process because its bus time is 4 and it is lesser than minimum. Minimum is this one. So I will be saying, okay, minimum is your bus time, that is 4, and your index is 1. Okay, now I will come here and I will say, okay, minimum is 4, my bus time is 4, 4 is equal to 4, but this condition will be false because the arrival time 8 and the minimum index variable arrival time is also 8. It is less than 8. It is false. Okay, now currently this is the minimum, but after the completion of this loop I should answer P4 as the minimum. See it will run or not. So here you can see again for I equal to 2 we will run and here we will see the minimum is actually which number, this 4. Okay, so we will come inside here. This arrival time will not satisfy this condition. 9 is less than 8. No, so we will leave. Now we will come to I equal to 3 here. Okay, now here 8 is less than 8. This 8 is less than your current time, right? And it is not completed, so we'll come here. Now minimum is 4, CPU burst is 4, and the ith process burst time is 2. So 2 is less than 4. Yes, so I will update this minimum. So see, minimum is updated with 2. Previously it was 4 and its index is 3. Okay, now again you will see this condition will not run. Okay, and again for I equal to 4, for this, because its arrival time is 10, 10 is less than 8, it will not run, right? So this way, after this for loops gets over, I will have the minimum as this 2 and index will be 3. So min index will be 3. Okay, so that means this P4 is selected. So this code is running for that thing also. Okay, now let's see which cases are handled by this code. So let's assume we have only two processes that are given into our question. Okay, and let's assume these processes are not present. Okay, only these two processes are there, and let's say this is 2 only and this is 7. Okay, so next you can assume that the current time is actually 8. Okay, and we are starting from the first process. This is our first process, this is our second process. Now here you can see the bus times are same. Okay, and this is 8 and this is 7 and current time is 8. So till 8 o'clock, which process should be selected as the minimum CPU bus time process? So as you can see, both are having the same bus time too. So till current time as 8, or you can say at 8 o'clock, which process should be selected out of P4 and P5? So here you can see this is P4, this is P5, this is same. Then we come to the arrival time. To break the tie of the same CPU bus time, we come to the arrival time. And here you can see this arrived earlier, so this P5 should be selected. Okay, so this code should give us that P5 is the process with the minimum CPU bus time. So we'll start from here and let's assume this is the 0th process, this is the first process. So current time is 8. Okay, and now we'll see the arrival time of this process, that is 0th process, is equal to 8, and this process is not completed. We are assuming both processes are not completed. Okay, so we'll come here and we'll say, okay, minimum is the int maximum and my bus time is actually 2. So 2 is less than int maximum. So I'll say minimum CPU bus time is 2 and the index of that process is 0. Okay, and after that I will not come here. Now for the I equal to 1, here I will see that yes, current time is currently 8. Arrival time of my this current process is 7. 7 is less than 8. Okay, and this process is not completed. So I'll come here and I'll see, okay, the bus time, that is this, is less than minimum. The previous minimum was 2. So 2 is less than 2? No. Okay, but 2 is equal to 2. So here you can see I have written if. I have not written else if. Okay, so you have to take care. So I'll say, okay, 2 is equal to. So I'll see, okay, my CPU bus time is same. So I have to break the tie based on the arrival time. So I will see that my current arrival time is 7. Okay, and the arrival time of the process, which was minimum in the last iteration. So you can see this was the minimum process. Okay, P4 was the minimum process and the arrival time of that particular process was 8. Okay, so this min index is having 0. So PS0.80 means this process. Okay, so this arrival time is 8. So that previous minimum process index person, so that previous process has the arrival time 8, that was minimum, but my is 7. So I came earlier, 7 is less than 8. Okay, so I'll see minimum will be now this. Okay, and the index of P5, that is 1, it will be saved. Okay, now I'll not go to the next process because I have only 2 processes, right? So this code will give me the minimum index as 1, that is I will select P5. So this is handling this case of the same CPU burst time, and you can check by yourself that if burst time are same and the arrival time are also same, let's say this is 2, this is 2, and this is 8, this is 8, and only these 2 processes are there, then which process should be selected when arrival time and burst time both are same? Then the first process, which is having the lower PID, it should be selected. So 4 is lesser than 5, that means this person or this process having the lesser PID should be selected. So you will see with the help of this code only, okay, this if, this can be selected, this P4 can be selected. So you can do it by yourself. So how we can compute CPU utilization? So percentage of the CPU utilization is the total length of the cycle minus the CPU idle time divided by total length of the cycle. So let's see. So here you can see we are first computing the total idle time. So why? Because here you can see in the CPU utilization percentage we have the two things that we have to compute: the length of the complete cycle minus the idle time. So let's compute first this. Okay. So in this example here you can see this is the idle time. So it is 8 minus 5, 3. For 3 unit of time, the CPU was idle. So total idle time after this while loop, it should be 3 unit. Okay. So what we are saying, okay, we have taken 2 variables. One is the previous, one is the first process. So this is a Boolean variable which is initially false. Okay. And this previous is actually telling me that if I am currently at particular process, then the last process was completed at which time? Okay, you tell me that completion time of the previous process, just previously completed process. So that completion time will be stored in this previous variable. Okay, and I am using this previous variable here. Okay, so let's see. So this is the previous thing that we have just seen, and these are the things that we can actually compute. So the completion time, turnaround time, okay, this is the simple thing that you can just compute by yourself. Now here is the total idle time that we are interested currently. Okay, so we are saying okay, total idle time initially it will be 0. Okay, and then what we are doing, as soon as each process is getting completed, we are updating this total idle time. Okay, so initially this P1 has started at 0. Okay, so this start time, it will be initially 0. Okay, so what we are doing, we are saying okay, currently, let's say initially the current time will be 0, so we'll say start time is 0. Okay, so for P1 this start time will be 0 because P1 is given by this code. Okay, so after computing everything, now we are saying okay, this thing. So before telling me this thing, for P1 what is the idle time? See, CPU was not idle before P1. See, we have to compute everything from the first process when it started. This you have to take care. Okay, let's say P1 started at arrival time is 2. Okay, if it is given as 2, then also you will say okay, my process started at 2. Okay, and it will run for its CPU burst time. If it is 5, then 2 plus 5 7. But I will not say okay, 0 to 2 CPU was doing nothing. No, I'm not taking this into my consideration. I'm saying if the first process started at 0, or it started at 1, or it started at 2, you start all the computation from here. Before that, whatever happened, we are not taking into that consideration. So for the first process, CPU idle time will be 0. Okay, so to just check that thing, I am saying okay, is first process, okay, this variable is equal true. Okay, so initially it will be actually true. Okay, so it is actually false. So initially it will be true. So I will say yes, for the first process it is true. So I will say okay, total idle time is 0. Okay, so for the first process it is 0. Now for the next process will be your P4. Okay, now when we will come to this current time 8, okay, after doing everything, okay, that I have not written then else part. Okay, after this there will be else part also, no, else current time plus. Okay, I have not written that thing, I have removed that thing for the time being. Now after this we have to change this is first process. Okay, now after this we have to update this is first process equal, or you can say equal false. Okay, after this will be false. Okay, we can just write inside this loop only is first process equal to false. So after this, every time this thing will run. Okay, this 0 will not run. Okay, now for the next process, this P4. Okay, let's say our current time is now 8. Okay, now this P4 was selected by this code. Okay, and the current time was 8, so start time will be now 8. Okay, we'll do all this thing. See here, is first process equal to no, so we'll come here. Okay, so how we are computing the idle time for other processes which are just in the direct continuation. So what we will say, okay, this is the idle time. We'll say okay, for the current process, what is the start time? It is the 8. And for the last completed process, what was their completion time? So for P1, their completion time was 5. Okay, so 8 minus 5, I will get 3. So the same thing I am doing here. I am saying the current process start time. The current process is designated by minimum index. That start time is 8. What is the completion time of the previous process? It is 5. It is stored here. Okay, so 8 minus 5, it will give me 3. But the question is, have I saved 5 inside this previous? So what will happen when I will run this code for P1? Okay, when I say okay, this is 0. So after this I will do this thing also, and I will say previous equal to what? Previous equal to my, you can say, completion time. Okay, completion time is this CT. When that P1 was completed, I will say that CT will initialize this previous. So that's why 5 was saved here. So for the next time when I came to this P4, I said, okay, previous was storing the 5. Okay, so this way, this idle time will be adding 8 minus 5, 3. So this 3 will be now added here. Okay, now you can just tell me that for the all other process, this idle time will be storing what value? It will be adding 0, 0 only, because now CPU is not idle. So again, I have given you the hint. You can run this by yourself. Okay, after this time, 0 will be coming from here, start time and the previous time, because for other process, 13 will be the start time and previous will also be this 13 minus 13 will be 0. Here also 17 minus 17 will be 0, because for P3 start time is this and P2 completion time is 17. So previous will be storing 17. Okay, 17 minus 17, 0. Okay, so this idle time I can store or I can use for computing the CPU utilization. So this is over. Now I have to compute length of the completion cycle. So length of the cycle means this process started at 0, completed at 23. So what is the length of this cycle? 23 minus 0, 23. Let's say if P1 started at 2, then 23 minus 2, it will be 21. That will be the cycle length. Okay. Now this is the code for this. So what we are actually saying, okay, the process may not run in this order like P1, P2, P3 and so on. Okay, they can randomly run on the CPU. P1 is running, then P4 can run. Okay, so last process that was completed was here in this example, it is P3. Okay, so this P3 will be storing the maximum completion time inside it. Okay, P3 will have 23 stored inside it as the completion time, and P1 it has the completion time as 5 and start time as 0. So this is the start time of the P1 and this is the maximum completion time which is stored inside P3. And as the process can come in random order, so what I have to do, I have to find this maximum completion time and minimum arrival time so that I can just subtract them and I can find the length of the cycle. Okay, so that's why what I am doing, I'm saying maximum completion time, I'm initializing it with the minimum value. Minimum arrival time, I'm initializing it with the int max. And what I will do, I will actually run this loop for all the n processes. Okay, so I will actually go for each and every process from 0, 1, 2, 3, 4, each and every process, and I will just find their completion time and I will go to their completion time and I will find the maximum. So I will find 23. Okay, and I will also go to their start time also. Okay, and I will find the start time, that is the minimum. Okay, I will find the start time of the P1 as the minimum, that is 0. So I have to compute this thing and I have to find this thing. I have to do searching. Okay, that's what I am doing so that I can do 23 minus 0. So here you can see I am saying, okay, what is the maximum completion time till now? Okay, comma, what is the completion time of the ith process? Okay, and then I am finding the maximum of them. For the minimum arrival time, I am finding the minimum between the current minimum arrival time and the ith process arrival time, whichever is minimum, I am finding the minimum. So this is like finding the minimum from the array and finding the maximum from the completion array. Okay, and after that, I am just finding the subtraction of them to find the length of the cycle. So length of the cycle will be placed here, total idle time will be placed here, divided by length of the cycle. It will give me the CPU utilization. Okay, so now let's see the throughput. The throughput is total number of processes completed per unit time. So formula is total number of processes. So in this example, we have 5. And length of the cycle that we have just computed, 23 minus 0. Okay, so it will be 5.23. So I hope now you have understood So I think now you have understood the code snippets, that how this SJF code will work. So now let's see the complete code of this program in C language. So here you can see we have the structure that I have discussed. Okay, then we have the main function and we have asked the total number of process. Okay, and we have defined other variables also. Then we asked it arrival time, burst time. Okay, and after that, this is the same code that I have discussed. Okay, so this code is finding the process with the minimum burst time till current point of time. Okay, this will give me the index. If index is -1, that means you just increment current time by +1 because there is no process inside the ready queue. Okay, otherwise if there is such process, I am finding everything. Okay, I am finding everything. Okay, so here you have to see the response time is equal to waiting time actually. Okay, for the non-preemptive codes or non-preemptive algorithm, response time actually comes to the waiting time. So completion time is start time plus burst time. Okay, turnaround time is completion time minus arrival time. Okay, and waiting time is the same thing. So you can see completion time is like the start time plus burst time. So what we are saying, okay, for the current process, take the start time and add the burst time in that. Okay, so that will give me the completion time. Okay, so let's say our process started at 5 and the burst time is 10. So 5 plus 10, 15. Okay, so this start time is very beneficial for us to give the current this start time is very beneficial for us to get the completion time. Turnaround time, waiting time, we have just applied the formulas. Okay, and we have added everything. This is the total idle time. Okay, and here you can see that we have declared is first process equal to true initially. Okay, and here you can also see is completed is initially false, right? Okay, now if we come down, the same code that I have discussed, it is written here, is first process is made false, previous is equal to current time, right? Now here we have computed the length of the cycle, the same code that we have just discussed. Okay, and after computing everything, we are just printing everything into the tabular form. Okay, completion time, their burst times, their waiting time, response time, and finally we are printing the output. Okay, and this is the code for the CPU utilization, idle time, length cycle, and so on. Okay, so let me run this code and you will be able to see it much better. Okay, so I will run for the same example that we have just discussed. So we have 5 process, then their arrival time, 0, 8, 9, 8, then 10, then we have to enter the burst time, 5, 4, 6, then 2, then 3. Okay, so this is the tabular form that I was discussing. Okay, and these are the outputs, averages of each and everything, throughput, and the CPU utilization is 86.95%. Okay, so now here is the C++ code. So here you can see again there is no as such difference. Okay, this code is actually same because we have not done any sorting like we have done in the our SJF example. Just the thing is, if I want to print everything till 2 correct decimal places, then I can use this thing, set precision. Okay, till 2 decimal places with the fixed. Okay, and rest of the code is same as the C program. So with just the changes, I have used the STL library max and min. Okay, max and min. So to use this max and min, I have used the header file algorithm. Okay, and I have not provided any definition of the max and min because they are present inside this algorithm. They are provided by the STL library, and this C limit is for the that you can say int max and the int min that we have used. Okay, the limit.h we have to use in the C program, and for the C++ we have to use the C limits. Okay, so I hope you have understood this code. So if you have any comment, question, suggestion, please write down in the comment box, and if you like the video, please subscribe the channel and press the bell icon for further notification of the videos. So see you in the next video with next program. Till then, goodbye.